Today we are discussing the topic of visual acuity and its relationship with light intensity. So what is visual acuity? Visual acuity is the eye's ability to see fine detail. A measure of acuity is the minimum angle subtended by 2 points that are barely able to be resolved by the eye. That is, the angle at which 2 separate points can be distinguished. Practically, this means that if someone is standing some distance away from 2 points that are 1 millimeter apart, they will only be able to see 1 point. However, as they get closer, there will eventually be a distance d at which the points are distinguishable. The angle at this distance is known as the minimum angle, which is what we're looking for experimentally. From this, we can deduce that the minimum angle is equal to the distance between the points, which is 1 millimeter, divided by the distance between the person and the points. Beyond what we've covered in class, we wanted to see how another variable affected visual acuity. Specifically, we wanted to explore its relationship with different light intensities. In order to test this, we conducted 2 trials. The first trial used 3 iPhone flashlights as the only sources of light on the 2 points. During the second trial, we only used 1 iPhone flashlight, but there will be more on that later. On average, the iPhone camera emits 7 lumens of light. The lumen is the SI unit for intensity. Since we used 3 iPhone flashlights, there were approximately 21 lumens total in the room. We started with a blank piece of paper and added 2 points, 1 millimeter apart, using a Sharpie. Then we started across the room and walked closer until the 2 points were barely resolved. At this point, we stopped and measured the distance from the observer to the points. This distance was 253 centimeters. Taking the original equation, we measured the minimum angle by dividing 1 millimeter, the distance between the points, by the distance between the observer and the points in millimeters. Since the distance was 253 centimeters, the minimum angle was 3.95 times 10 to the negative 4 radians. Next, we conducted trial 2. This time, we only used 1 iPhone camera. As you remember, iPhone flashlight is 7 lumens. The same procedure was performed in order to identify the difference that less light makes on visual acuity. An observer started some distance away where the points were indistinguishable, and moved closer to the points until they could be identified as 2 separate points. This distance was 200 centimeters. Taking the original equation, we measured the minimum angle by dividing 1 millimeter, the distance between the points, by the distance between the observer and the points in millimeters. Since the distance was 200 centimeters, the minimum angle was 5 times 10 to the negative 4 radians. We wanted to compare this to the angle that we found in trial 1 when the light intensity was 3 times brighter. We decided to find the percent difference. We subtracted the minimum angle from trial 1 from the minimum angle from trial 2. Then we divided the difference by the minimum angle from trial 1 and multiplied by 100 to get 26.6% increase in the minimum angle between the 2 points. Since this angle increases when there was less light, you must stand closer to the 2 points in order to distinguish them.